So let's start a new topic. The next topic is the equation of plane progressive wave. Plane progressive wave. Equation of plane progressive wave. That is when the wave in the string is moving like this. So we have to find this equation. To understand this, what you have to consider, suppose there is a string. This is the string, right? It is connected to somewhere and the tension in the string is T. This is under tension T, right? And this is the end point. This is fixed, you can assume, or you may assume this is the long string. When you move it up and down, so what will happen? When you will move up and down, number of train pulses, right? Number of train pulses will be produced, which form the wave, right? Listen one thing. If you consider any point, suppose this is the point, this is the another particle, another particle, another particle. So different particles, right? Different particles are arranged side by side along this length, you can assume, right? So number of particles are arranged side by side, right? You can assume like this. Are you getting or not? So when you will move this up, right? What will happen, right? Number of particles, right, will be moved like this. Is it clear or not? Right. When you will move down, right, what will happen? It will be the, after some time, it will be the shape of the string, right? When you move it down, so what will happen? The shape of the string will be like this. Are you getting or not? Like this. And when you complete one cycle, so this is the shape of the string will be there. Are you getting? Like this. It will be the shape of the string, right? But all these particles will be in straight line, right? Like this. They will be at rest. Only the particles which are connected to this side by side, they will start moving. Is it clear or not? So it is initially at all the particle at rest. When you, right, when you hold this particle and move up and down by some oscillator, suppose this is the oscillator, right? This is what? This is the oscillator which can move, right? This is the oscillator. Oscillator is a machine, right, which can oscillate, or your hand may be in place of oscillator. If you move up and down your hand may be called the oscillator. Listen one thing. If you consider this is the particle, this is the particle P. After some time it is the position of particle P. After this time this is the P, this is the P, right, and this is particle P, right? So you will see that this particle is doing what? This particle is performing SHM. Are you getting or not? On its mean position. Suppose this is the pen. What is SHM? If it means if a particle move to and fro about its mean position such that acceleration is proportional to minus x, then its motion is SHM. So if this particle is performing SHM, its side by side, its particle nearby it, or every particle start performing SHM. Are you getting? Here it is moving up, then its velocity, suppose this is the plus A, right? Its velocity is 0 over here. Then it is when it reaches to this point, this is suppose the minus A. When it reaches to the highest point, its velocity become what? Its velocity at the highest point become what? 0. This is the at plus A. When it reaches to this point at the mean position, its velocity is maximum again. Its velocity is maximum again, right? When it reaches to the right this position at the minus a, its velocity become 0, and when it reaches to the mean position again, when it reaches to the mean position, it is moving towards its velocity becomes 0 over here, right? Its velocity becomes 0 over here. In the mean position, its velocity is maximum again. Are you getting or not? So if you assume this is to be the x-axis, this is to be the x-axis, and this is to be the y-axis, and this is x is equal to 0. So what will you write? You will write that at x is equal to 0, if at x is equal to 0, particle is performing SHM, right? SHM. Amplitude is a. Therefore, the y as a function of time t. If you consider only this particle, it is performing SHM, amplitude is a, angular velocity is omega, angular frequency is omega. So what is the displacement equation in y direction? You will write, say, a sine omega t. This is what? This is the displacement of particle, right, at x is equal to 0 as a function of time t. Where what is a? A is the amplitude, right? Omega is equal to 2 pi f is equal to 2 pi by t. T is the time period frequency. Omega is the angular frequency. You understand this thing or not? You tell. Listen one thing. Tell me, if this particle is performing SHM, this particle, this is the string, I am considering this particle. So you tell me, when this disturbance is created, right, at this point, so if you assume that speed of the wave is v, what is the v? V is the speed, S-P-E-E-D. Speed means scalar quantity. Speed of the wave depends upon the property of this string, and the property is the elasticity and inertia, you will remember always. But this particle or all other particle are moving to and fro, up and down, perpendicular to the direction of the propagation of the wave. All right, listen one thing. Not only this particle, rather every particle start oscillating about its mean position. Suppose you consider this is the particle, right? It is at rest right now. It is at rest. After some time, it move up, then it will come down, similar to this. So when you start oscillating this particle, so after some time, every particle start oscillating as the particle oscillating x is equal to 0. You understand or not? Right. So not only this particle, this disturbances propagate in the x direction. Are you getting or not? Varsha, that is called the wave. If this is the one pulse, or you can say one wave, and number of pulses, a train of pulses produce the wave. All right, listen one thing. If you consider any point, suppose this is the particle at x is equal to x. This is the particle at x is equal to x. Right. So what will happen? As I told you yesterday, if you keep this a paper boat and this is the water surface, when the disturbance is created, it will start oscillating. Why? Because they are connected to each other, right, and restoring force due to elasticity is produced, and therefore this molecule start acting force upon this molecule start for acting upon this. So disturbance is forwarded or propagate in the x direction, and this particle is also start oscillating of the same amplitude. Suppose this is the particle, so this is a plus a and minus a. After some time, this particle start oscillating. So listen one thing. If you consider number of particles, if you start oscillating this, all the particle will start oscillating after some time and they produce the wave. You understand or not? Please tell. As you can see on the surface of the water, if you drop some stone somewhere, all the particle about their mean position will start oscillating, right? So this is the displacement of the particle y as a function of time t. I am writing, therefore, if disturbance is this disturbance is this disturbance disturbance is produced at x is equal to 0, at x is equal to 0, right? This is the disturbance, means suppose this is the oscillator. It is forwarded, it propagates, right, with speed v, right, along the direction of wave, along the direction, with the speed v, along the direction of wave, and all other particles start oscillating, right? Start oscillating as particle at x is equal to 0, at x is equal to 0. That is all other particles start copying the motion of particle which was produced at x is equal to 0. What the motion is produced as x is equal to 0, this particle start copying the motion of this particle, but after time t. After some time t, this distance reaches to this point. It means if you consider this particle at distance x, the motion of the particle will copy the motion of this particle, but after some time t. What is that time? Please tell me. What is the time? After what time this particle will copy the particle at x is equal to 0, right? You assume this the x is equal to 0, suppose, and this the particle p. Are you getting or not? The particle at x is equal to x will copy the particle of x is equal to 0, but after time t, what is that time you tell? Say x is equal to v into t. The speed of the wave, that is this wave pulse, will reach to this point after some time t, and what is the time t? Say x upon v. Is it clear or not? Are you getting this? Varsha, please tell. What does it mean? What is the displacement is being produced at this point? The same disturbance will be of this particle p, but after some time. What is that time? Suppose this is the distance x, the speed is v, so the distance will propagate after time x upon v, or distance will reach at this point after time x upon v. Is it clear or not, you tell? Right? Copy this first. So what you conclude the discussion? Listen one thing. This is the wave. Suppose this is the very beautiful wave when you will move up and down your hand, right? But the thing is that this is not a very tough concept if you assume that, and it is actual. Every particle is doing what? Say SHM. And SHM, we have discussed the SHM. So if this particle is doing SHM, so this particle will also execute SHM. So what they are doing? They are doing SHM about their mean position, like that. So if it start SHM early and it start SHM doing SHM after some time. So if this is the displacement, what is this? This is the displacement of the particle as a function of time t, but x is equal to 0. Are you getting or not? What the y you will write? This is the displacement of particle P at x is equal to 0 as a function of time t. Is it correct or not? So, what is the displacement you will write of this particle? Please tell. Can you write the displacement of this particle? Yes, we can write. What is that? Displacement of the particle. Displacement of the particle, right, as a function of time t at x is equal to x is equal to displacement of a particle, right, at x is equal to 0. Are you getting? At x is equal to 0, because this particle is copying the displacement of the particle at x is equal to 0. At x is equal to 0, but which was produced, right, time x upon v before. Is it clear or not? Right. Little change you can write. In the book, it is written as y displacement of the particle at x is equal to 0 as a function of time t. So you should write like this: displacement of particle present at distance x at any time t is same as the displacement of the particle at present at x is equal to 0, but before time x upon v. You understand this question on this thing or not? You tell. I'm writing displacement of particle p at x is equal to x at any time t, right, at any time t is equal to, right, is equal to displacement of particle present at x is equal to 0 at x is equal to 0, but produced t is equal to time x upon v before. Is it clear or not? It will copy, right, it will copy the displacement of this particle, right, after some time t, or you can say what the disturbance will reach at this point p. It was already produced at x is equal to 0. Is it clear or not? And if this distance is x, so what the time it was produced? So this particle will copy the displacement of this particle, but which was produced some time before, x minus v upon v4. Is it clear or not? Listen one thing. What is the displacement of x is equal to 0? This is the x is equal to 0 as a function of time t, right? So if you want to write, listen, if you want to write the displacement of the particle at x is equal to 0, but time t minus x upon v. So what you have to do? Please tell. In place of time, you have to put x upon v. Is it clear or not? So the displacement of x as a function of time t, I'm writing of the displacement of this particle, I'm writing as a function of time t is equal to a sine, right, omega, right, it is omega. If we change the time t, we can get the displacement t minus x upon v. Is it clear or not? So a sine, yes, multiply omega t minus omega upon v into x, and this omega upon v is called the propagation constant k. If you treat this as a constant k, a sine omega t minus k into x. So this is the equation of the traveling wave along the positive direction, where what is k? K is omega upon v, and it is called the propagation constant. So this is called the equation of traveling wave in positive x direction. Is it clear or not? In positive x direction. Do you understand this thing or not? Varsha, please tell. Any doubt you want to ask, right? Copy this. So what do you understand by this? That every particle is performing SHM. What you have to do, we have done the SHM in a very good way, so we can discuss all other things, right, like this. But the thing is that instead of considering the displacement of x is equal to 0, we will discuss the displacement of any particle present at x. Listen one thing, at different x, at different x, at different x, at a particular time, at different x, their displacement will be the different. For example, if you take, this is the snapshot, this is at t is equal to time t sometime, right? So its displacement is different, its displacement is different, its displacement is different, its displacement is different, its displacement is different. So every particle is performing SHM, and different displacement of the particle will be there. You understand or not? Another thing, if this particle is performing SHM, only you consider this particle, right? So this particle velocity will be, right, different from the speed of the wave. The speed of the wave is given by omega by v is equal to k, or v is equal to omega by k. This is called the speed of the wave, but the velocity of the particle will be different. You understand or not? Listen one thing, if you the another way to write this equation is, what is this? Although it is called the equation of traveling wave in positive x direction, right? But this is nothing but, this is the displacement of the particle at any distance x at any time t, right? This is the equation which may be written as a sine, right, instead of omega you may write 2 pi by t into t. This is the omega, and the k is nothing but omega upon v is equal to 2 pi f upon v. And what is the v? The v is equal to f into lambda, f into lambda. F will cancel out 2 pi by lambda. So this is called the propagation constant. This k may be also written as 2 pi by lambda. It is called the propagation constant, 2 pi by lambda into x, right? A sine 2 pi, right? A sine 2 pi t upon t minus x upon lambda. This is the y as a function of time t. Are you getting or not? This is the another way of the another form of the equation of traveling wave. This is the equation of traveling wave. This is the another form of the equation of traveling wave in terms of time period, right? In terms of wavelength. Is it clear or not? Like this. Listen one more thing. Sometime this, it was the displacement of the particle. So what will you say? What is the initial phase of this initial phase of this particle? We have taken 0. So instead of the initial phase, phi is already given, right, for this. So you may also write in terms of the initial phase a sine omega t minus kx plus phi. This is the equation of traveling wave if the particle at x is equal to 0 has already some initial phase. So we have to add the phi also. Is it clear or not? And one more thing, when you propagating this, this is the this is the propagation in positive x direction. This is in positive x direction, in positive x direction. This is also in positive x direction. But if it is moving to the negative x direction, right, the equation of traveling wave become a sine omega t plus kx. It become plus because it is going in this way, right? And this is in negative x direction. So if it is negative, if it is positive, then it is moving towards the negative x direction. And for the positive x direction, we have found the right equation. Is it clear or not, you tell? So this is the derivation of the equation of traveling wave. Although it seemed to be very tough, but it is nothing but displacement. It is the kinematic. We are going to discuss the kinematic only in the form of wave motion, right? Copy this. So if you write the general equation of traveling wave, equation of traveling wave, equation of traveling wave, now it is clear, it is nothing but the displacement of the particle, right? Any particle at x is equal to x, right? At x is equal to x, and it is performing oscillation, right? If what is the equation of traveling wave? You will write y as a function of x time t is equal to a sine omega t minus kx. Are you getting or not? So if this particle is performing SHM to and fro, the amplitude is a. So can you find its? Can you write its velocity? Velocity of particle. Velocity of particle. Right at x is equal to 0, at t is equal to time t. How would you write? The velocity of particle is nothing but partial derivative of y with respect to t. What does it mean? Although this displacement does not depend upon only one variable, rather it depends upon x and t. For different x, for different time, the displacement is same. Displacement is different. But now I am considering the velocity of particle at x is equal to x at time t. So the x is fixed. I am considering only this particle now, and this is performing oscillation. So we have to differentiate this displacement with respect to time t. That is what this is called the partial derivative. What does it mean? We will assume x to be constant, right? This is the meaning of this partial derivative. So if you differentiate this expression with respect to t, so a differentiation of this, only t is the variable, sine differentiation is cos, right? And the chain rule, differentiate this once again. So what will you get? Omega into 1 minus 0, because k and x assumed to be constant. So omega comes in for, right, before this, omega t minus kx. So what is it? It is the velocity of the particle at x is equal to x at any time t. Is it clear or not, you tell? This is the displacement of the particle. Now if you want to write the acceleration, yes, acceleration, what to do? Again you have to differentiate. Acceleration of particle is nothing but partial differentiation of dp upon dt, that is d square y upon dt square. Is it clear or not? So again, if you want to differentiate a omega, what is the differentiation of cos? Say minus sine omega t minus kx. This is the differentiation, all right, into differentiation of this expression by chain rule into omega into 1, t differentiation is 1 and its differentiation is 0. So this is omega only. Omega is minus a into omega square. This is sine omega t minus kx. So this is the acceleration of the particle p. Is it clear or not, you tell? So this is the acceleration of the particle p, right? And this is the velocity of the particle p. You may write this is the acceleration as a function of x and time t. This is the ap. Is it clear or not, you tell? Right. Okay, wait for 1 minute. So this is the velocity and this is the acceleration. One more thing. Now I will tell you the differential equation of traveling wave. Differential equation of traveling wave. Right. First copy this, then I will explain. Copy. Differential equation of traveling wave. We are going to discuss. If this is dy upon dt, listen one thing, this is the y is equal to a sine omega t minus kx, right? So what is dy upon dt? Is equal to a omega cos omega t minus kx, right? What is the d square y upon dt? Square. Differentiate again with respect to time t, then you will get a omega, right? Its differentiation is minus sine omega t minus kx into omega. So it is equal to minus a omega square. right? Sine kx minus, sorry, sine omega t minus kx. Fine. So this is d square y upon dt square. Del d square y upon del t square. This is the equation number 1. Right. Now, although this is the velocity of the particle, this is the acceleration of the particle. All right, like this. But if you find the dy upon dx with respect to x, if you differentiate this, so a cos omega t minus kx, this is the partial derivative of y with respect to x, right, into sine differentiation is cos, again by chain rule differentiate this, mean now the time assumed to be constant, right, because we are doing differentiation with respect to x, so this is constant, so differentiation is 0 minus k into what is the differentiation of x, the differentiation of x is 1, so it comes to be minus ka cos omega t minus kx, right, this is the dy upon dx. Are you getting? Now if differentiate once again, that is d square y upon dx square. This is the double differentiation, we can say. This is also called the double differentiation with respect to time. This is called the double differentiation with respect to x minus ka. Cos differentiation is what? Minus sine omega t minus kx. Differentiation of this once again with respect to x. Omega t is a constant, minus k, the differentiation of x is 1, right? This is minus k minus minus, again it become minus, right? It become minus k square a sine omega t minus kx. This is the equation number 2, and this is d square y upon dx square. Is it clear or not? So this is the double differentiation with respect to t, this is the double differentiation with respect to x. Now divide 2 and 1. So this is d square y upon dx square divided by d square y upon dt square is equal to minus k square a sine omega t minus kx divided by minus a omega square sine omega t minus kx. So it will cancel out, right? So what will left? A will also cancel out, minus minus will also cancel out. It is k square upon omega square is equal to k by omega square. And what is the v? Did you remember what is the speed of the wave? Listen, the velocity of the particle up and down is different, right? And the speed of the wave is equal to omega by k is different. This speed of the wave depends upon the elasticity and inertia, right? And this speed of the particle depends upon what? It depends upon the oscillator, what you are using the oscillator. The particle speed, any particle, every particle is performing SHM, right? So their speed depends upon the parameter of the oscillator, but by which rate the wave is propagating, it depends upon the string, it depends upon the medium. You understand or not? So the velocity of particle is different, speed of the wave is different, right? So here omega by k it is 2 pi by t, right? Omega by k or k by omega, it is 2 pi by t at 2 pi by lambda, k is equal to 2 pi. So v is equal to f lambda. Yes, omega by k was the speed, so it may be written as 1 upon v square. So multiply this, v square d square y upon dx square is equal to d square y upon, or you may write d square y upon dx square. It is multiplied by this, it is 1 upon v square into del square upon del t square. Is it clear or not, you tell? Right. So this is what? This is called the differential equation of the traveling wave, right? it is some numericals are also asked upon this differential equation of the traveling wave, right? Copy this. So the equation of traveling wave, we have seen x comma t, y as a function of x comma t is equal to a sine omega t minus kx, right? It may be written in this form. Also, it may be written as a sine omega t minus kx plus phi. The phi may be anything, right? Listen one thing. If you make the phi, if phi is equal to pi, right? So what the equation you will write? Please tell. A sine omega t minus kx plus pi. It is theta plus phi. So what is theta plus pi? You tell. That is sine pi plus theta. Can you tell? If you assume this the theta plus pi, that is pi plus theta is equal to what? Say minus theta. It may be written as sine kx minus omega t. Is it clear or not? You tell. Sorry, sine omega t minus kx. You understand? And if you adjust the minus sign, a sine kx minus omega t. So listen one thing. This is equation of traveling wave we have seen. This is also the equation of traveling wave. Whether it is written as kx minus omega t or omega t minus kx, both are correct. Or if it is written as kx minus omega t plus phi, it may be written somewhere a sine kx minus omega t plus phi, right? Whatever it may be written, because the phi may be the pi by 4, pi by 2. It is the initial phase, which may be anything. But especially the student and teachers are also confused with this two expression. What are those expressions? You try to understand. This is the equation. If you take at t is equal to 0, at t is equal to 0, at t is equal to 0, it becomes sine kx. All right. And if you write this equation, x comma t, a sine omega t minus kx, and at t is equal to 0, if you write the y, a sine minus kx is equal to minus a sine kx. So at t is equal to 0, the snapshot of the wave you take, although wave is always traveling, right? It is changing its shapes continuously. But at t is equal to 0, what will be the shape of the wave? Sine kx. What is the graph of the sine kx? If this is assumed to be the x, the graph of the sine kx will be this. This is the y, this is the amplitude, right? This is the minus a. Are you getting or not? K is nothing but 2 pi by lambda into x. All right. So this distance assumed to be the lambda, and this is the half wavelength. It is lambda by 2. Is it clear or not? You tell. Understood? So this is the graph of, this is the snapshot of this type of wave. But if you want to draw the snapshot of this type of the wave, what will you have? A sine omega t minus a sine omega t. It means the graph is like this. Are you getting or not? This is the x. So this is the shape, right? Above the axis, this is positive. Initially it is negative. So this is the difference between a sine omega t minus kx, right, and kx minus omega t, right? So this is what? Again, it is lambda, right? It is plus a, it is minus a. Is it clear or not? You tell. The difference. In this wave, the phase phi is ahead with this wave. Is it clear or not? So if you are writing the a sine kx minus omega t, its snapshot is like this, and its snapshot is like this if it is omega t minus kx. But both are correct. In the question, they may give the equation of traveling wave, either kx minus omega t or omega t minus kx. Also, they can give omega t plus kx, right? So that is the negative direction moving. It is moving, this wave and this wave are moving in positive x direction, positive x direction. That's like, right? This type of the question is asked. If this is the equation of the wave, which of the following represent the correct figure for the traveling wave, right? So students are confused, it is right or it is right, or they may give some other configuration also, right? Copy this. So read this question. In this question, the equation of traveling wave, as you know, the equation of traveling wave is nothing but the displacement of the particle performing SHM at distance x at any time t. And here it is represented by 0.05 sine, right? It is pi by 2 10x minus 40t, right, minus pi by 4, right? So tell me, it is traveling in positive direction or negative direction? First of all, tell. It is traveling in, Varsha, positive direction, because minus is coming. So pi by 2 into 40t minus pi by 4. So 0.05 into sine. This is what? 5 pi x, right? 5 pi x minus 20 pi t minus pi by 4. Is it clear or not, you tell? So in the A part, they are asking the wavelength, frequency and the wave velocity, that is the wave speed. So you will compare with A sine kx minus omega t plus phi. So the amplitude is what, you tell? 0.05. The unit over here is, it is given in meter. So it is in meter, right? Amplitude is in meter. What is k? Is equal to 5 pi, is equal to 2 pi by lambda. What is omega? Is equal to 20 pi, right? What is the phi? The initial phase is minus pi by 4. I think you understand. This is 2 pi by t, right? Or are you getting? So what is the wavelength? Please tell. If you compare, the lambda is nothing but 2 by 2 pi by 5 pi is equal to 2 upon 5 is equal to 0.4 meter. Fine. Lambda is what? 0.4 meter. This is the wavelength. Fine. And what is the B part? Frequency. So this is nothing but 2 pi f is equal to 20 pi. So frequency is what? Say 10 hertz, right? What is the wave speed? Is equal to omega by k. If you remember, this is what? Omega by k. What is omega? 20 pi. What is k? Is equal to 5 pi. The speed is what? 4 meter per second, right? 5 chok please. 4 meter per second, right? This is the, and it is in positive x direction. Is it clear or not? Right. So this is the A part, right? Copy this first, then I will discuss B part. So in the B part, what they are asking, please tell. The particle velocity. Obviously, this is the particle displacement. So how to find the particle velocity? See, dy upon dt. So you have to differentiate this once again. The particle velocity you have to find, right? First differentiate this. This is 0.05 as it is. The differentiation of sign is what? You will say cos. This is, I am writing this cos differentiate. I'm differentiating this equation 0.05. The differentiation of sign is what? Say cos 5 pi x minus 20 pi t minus pi by 4, right? Differentiate this once again with respect to time t. If you differentiate, its differentiation is 0, minus 20 pi, the t differentiation is 1 and the constant differentiation 0. So you have to multiply by minus 40. So dy upon dt is nothing but 0.05 multiplied by minus 20 pi cos 5 pi x minus 20 pi t minus pi by 4. Is it clear or not? But the velocity of the particle you have to find at x is equal to 0.5 and t is equal to 0.05. What does it mean? If you want to find the velocity of this particle, you put x value and you put t value, right? First simplify this. This is 0.05 into 20, right? So this is how much? 100, right? Into 10 to the power minus 2, that is 1. So it is equal to minus 1 cos 5 pi. The value of x is 0.5 minus 20 pi into t 0.05, right? Like this, minus pi by 4 is equal to minus cos 2.5 pi, right? And how much is this? Is minus pi again, getting 20 into 5, right? 100, and it is 1 minus pi by 4. All right. So it is how much? This is 2 pi plus pi by 2. It may be written as what? 2.5 pi is equal to 2 pi plus pi by 2 minus 5 pi by 4. So pi by 2 minus 5 pi by 4, 2 pi minus 5 pi minus 3 pi by 4, right? So it is nothing but may be written as 2 pi minus 3 pi by 4. What you will write? 2 pi, 8 pi minus 3 pi by 4, 5 pi by 4. So it comes to be, when you will simplify all this thing, it is 5 pi by 4. All right, 5 pi by 4. What is the 5 pi by 4? Please tell. Pi plus pi by 4. So it is what? Pi plus pi by 4. It is minus cos pi by 4, right? Pi plus theta. And this is 1 by root 2. The velocity of the particle is plus 1 by root 2 meter per second, right? For 1 minute. 1 by root 2. Answer is not coming. Oh, wait for 1 minute. This is the pi's left. 20 into 0.5. It is pi. It is pi. Right? Pi. So it is pi by root 2. When you will simplify, you will get 2.2 meter per second. Is it clear or not? Copy this fast. So how to find the acceleration? Please tell. Differentiate it once again. For the acceleration of the particle, d square y upon dt square, that is, you have to differentiate once again. Listen, when you will differentiate it once again, right, it remains as it is. This is equal to what? When you will multiply, it is what? Say minus pi. So minus pi as it is. What is the differentiation of cos? You will say minus sine 5 pi x minus 20 pi t minus pi by 4. Multiply. If you differentiate with respect to t, right? So its differentiation is what? 0 minus 20 pi minus 0. So minus 20 pi is multiply, it becomes 20 pi square. Or you can say 20 pi into pi. And it become, listen one thing, minus, this is minus, this is minus. So it comes with minus sign. It is sine pi x minus 20 pi t minus pi by 4. This is the acceleration. But this acceleration we have to find what? At time, at x 0.5, at time 0.05. So it is equal to what? Say minus 20 pi square, you can say. Fine. Listen one thing. When you will put the value of x and time in this expression, right? No need to calculate again. 0.5 and 0.05 when you will put, when you will simplify, what will you get? Pi by 4. So this is pi by 4. Is it clear or not? You tell. Sine phi, x values 0.5, 20 pi, t values 0.05 minus pi by 4. This inner calculation, right, will be the same or not? And you will get finally, wait for 1 minute, sorry, you will get finally 5 pi by 4, right? 5 pi by 4. You will get this is 5 pi by 4. Fine. When and sine pi plus pi by 4, although it is also equal to minus sine pi by 4. Is it clear? So minus 20 pi square, it may be written as minus sine pi by 4, minus minus plus 20 pi square sine pi by 4. What is the value of sine pi by 4? 20 pi square into 1 by root 2. Is it clear? And this is 10 pi square root 2 meter per second square. Is it clear or not? So what the answer you will get finally? Although the pi square is approximately say 10, so 10 into 10 into 1.41, so it is 141 meter per second square is the acceleration of this particle, right? Copy this.